Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at ammonia. We're going to go over the FAQs and what you need to know about it chemically and what you need to know about it for water testing. So what is it? It is a nutrient that contains nitrogen and hydrogen. It's a chemical formula, NH3, in unionized state with and NH4 in iodized form. And total ammonia is a sum of both NH3 and NH4, and total ammonium is what's measured analytically in water. So why is it important? Well, ammonia is the perfect nitrogen-containing nutrient for plant growth, and it can be converted to nitrate, NO2, and nitrate, NO3, by bacteria and then used by plants. And nitrate and ammonia are the most common forms of nitrogen in aquatic systems, and nitrate predominates in unpolluted waters. Nitrogen also can be an important factor for controlling algae growth when other nutrients such as phosphate are abundant. If phosphate is not abundant, it may limit algal growth rather than nitrogen. And ammonia is excreted by animals and produced during decomposition of plants and animals, thus returning nitrogen to the aquatic system. Ammonia is also one of the most important pollutants because it's relatively common, but can be toxic, causing low reproduction and growth or death. And the neutral unionized form, N3, is highly toxic to fish and other aquatic life. So how is it measured? Ammonia is analyzed by chemical titration, and the method is used in most kits called the cyclic method. And always measure pH and temperature when you measure ammonia. Without these, the other measurements will be difficult to know the toxicity of ammonia. And the careful reporting of ammonia test results is very important, so you don't simply tabulate your results as NH3, because the abbreviation is used for both total and unionized ammonia. You want to be sure you indicate which you're reporting, and the results can be expressed as total ammonium, milligrams per liter, unionized ammonia, milligrams per liter, total ammonium as N, or milligrams per liter, and unionized ammonia as N, or milligrams per liter. So just for an example, if you measure pH and temperature, you can convert total ammonium values to unionized ammonia using the attached table. Your total ammonium, the pH, the temperature, and your sample from a freshwater stream. You want to find the pH. Left side of the table, find 25 degrees. Freshwater at the top of the table, and the intersection given the unionized ammonia, and then you get your value. You also have the unionized ammonium, the total ammonium, times the percentage unionized, and you can see what this comes here in unionized NH3. And as N values are based on the nitrogen component to the molecule to convert readings using equations and tables. So how does it affect the water? Well, natural factors can affect the concentration of ammonia, including algae growth, decay of plant or animal or fecal matter, and other aspects of nitrogen cycling can also affect the amount. So what are the acceptable ranges? The toxicity of ammonia critically depends on the pH and temperature. The unionized N3 is more toxic than the ionized N4. As pH increases, NH4 is converted to NH3 and toxicity increases. And higher temperatures also favor more toxic form. So it's very important you compare the values of ammonia correctly, and you must compare total ammonia to total ammonium, and compare the unionized ammonia to the unionized ammonia. And what are some objectives they're trying to reach? There's not currently one, but they're taking a look at ammonia to see how they can understand it. You can use these equations to figure out how much is in there and how it affects the water as well. So this is all great information, and ammonia can be measured in different ways. This is a good way to test it. So how do you know if your levels are high? Well, as we can see, the only way to know if your levels of ammonia are high in water is to have it periodically tested.